Now, this is where specifically I speak about broadband technologies that I've mentioned in the previous video. So specifically, I'm going to cover DSL broadband technology. I'm going to cover cable internet as well as fiber optic internet as well. So these broadband technologies, we know that, as I've mentioned in the videos previously, that they provide high speed. They also provide always on connection or internet access, or you can call it 24/7 internet access because they use a different transmission media and infrastructure. Each of these broadband technologies, including the ones I'm going to continue with in the next video, um, they they can be compared or they differ in terms of their speed, they differ in terms of their reliability, their cost, their coverage, as well as their underlying physical principles. Now, let me start with DSL. DSL is the first broadband technology. DSL is the digital subscriber line. This broadband technology transmits data or digital data over your traditional copper telephone lines, but it does not interfere with phone calls or phone services. So how it works is that it uses within the copper line of the telephone, there are frequencies, and there are two types of frequencies. There are higher frequencies or higher frequency band, and there's a lower frequency band. Now, DSL uses the higher frequency band within the copper telephone line, which are not used. Those frequencies are not used for voice communication, which means that there's a splitter which separates the two frequencies, the low frequencies and high frequencies. The low frequencies are usually for voice services, whereas the high frequencies they're intended for internet data, right? So DSL requires a DSL modem as well as a DSLAM. So the DSL modem is usually at the customer premises now, and whereas the DSLAM or, or the DSL access multiplexer is usually at the telephone exchange, right? Now, DSL, there are different types of DSL technologies. You can classify them in terms of how symmetric they are, right? So there is asymmetric DSL. The reason why it's realized or called as asymmetric is because when you compare download speeds versus upload speeds, you have faster download speeds compared to uh, upload speed. That's why it's asymmetric, right? And then that's the first like DSL technology, and then the other one is the very it's called the very high bitrate DSL, right, or VDSL. The reason why it's has a very high bit rate is because over short distances it has usually has higher speed, but over long distances that speed usually gets reduced, right? So over short distances you have high speed. That's why it's a higher, a very high bit rate DSL. And then there's symmetric DSL, which also implies that when you compare the download speed versus the upload speed, they're equal, right? But the type of DSL is mainly used for businesses, right? Um, the speed range of DSL technologies, depending on the type of DSL it is, it's usually for asymmetric DSL. It's you have speeds from 1 megabits per second up to like 24 megabits per second. And then for VDSL or very high bitrate DSL, you have speeds from 25 megabits per second all the way up to 100 megabits per second. That's a very high speed, but remember, it's heavily reliant on distance. This DSL technology, broadband technology, is reliant on distance from the exchange, telephone exchange. So the further you are away from, the telephone exchange, meaning like hundreds of kilometers away, thousands of kilometers away, that speed gets reduced, right? So it suffers um, that limitation, right? So again, there are advantages of this type of broadband technology, which of course which help us to differentiate it from other broadband technologies. Now, DSL in particular is it just uses existing telephone lines. It doesn't require any like new infrastructure. It is highly affordable because you don't need much infrastructure, so people can afford it. Businesses can afford it as well, and the also limitations of this technology, such as over like long distances, they are the speed or the bit rate gets reduced, right? So it's heavily dependent again on distance. That's a limitation that this type of technology or DSL suffers from. Again, um, in terms of infrastructure, the infrastructure is it needs can age in some regions, right? And the other broadband technology is the cable internet, right? This type of internet um, or broadband technology delivers or transmits data via coaxial cable TV infrastructure, right? And that TV infrastructure usually consists of cable modem, or the way it works is that it uses cable modem, which is connected to a cable modem terminator system at the service provider's facility. So this cable internet, um, somehow similar to the DSL broadband technology, it it uses the different frequency channels within the coaxial cable for television signals, for voice services as well, including uh, high internet data, right? Which means it uses sometimes it uses higher frequencies for internet data and television signals, and low frequencies for for voice services, right? And this type of broadband technology is speeds from 10 megabits per second up to uh, like 100 megabits per second. So it's actually faster than your DSL broadband technology. Then it has obviously has several technical advantages, uh, and that includes like it's usually highly available in like urban areas, and it's not heavily dependent, on distance, like like with DSL, but it suffers from limitations as well. This type of technology, and that is the neighbor users, because it's available in like urban areas. The neighbor users have to share the bandwidth, which means that during peak usage times, the speed gets reduced because of an increased number of users, and infrastructure as well needs maintenance. And then the other type of broadband technology that I'm introducing is fiber optic internet. I've already spoken about fiber optic internet in the past videos. Go and look at that. Um, But this type of technology transmits data, right, as pulses of light, which travel through, glass or plastic optical fiber, right? And how it works is that it doesn't use like electrical signals like your DSL as well as cable internet. Instead, fiber optic internet uses, light signals that travel or that are generated rather by, lasers that are generated by LEDs, right? And um, fiber optic internet, or the light that is transmitted um, and travels to the fiber core using something called total internal reflection, right? And I'm going to explain more in detail what that means as we go along, right? But that allows, since light travels through the fiber core, uh, using the total internal reflection, that allows extremely high speed. That's why fiber internet is extremely fast, right? It allows extremely high speed, low latency as well. Not only low latency, but also minimal signal loss over long distances, right? And the speed ranges. Remember, we're comparing all these broadband technologies in terms of their speed. As I mentioned at the start of the video, we're comparing them in terms of their speed, their cost, their reliability, their coverage, as well as the underlying physical or design principles, right? So in terms of speed, fiber optic internet has speed that range from 100 megabits per second all the way to more than 10 gigabits per second. So it can exceed 10 gigabits per second. So it is extremely fast, right? And as well, it has technical advantages when you compare it to the other two previous um, broadband technologies, the DSL, as well as your cable internet, right? First is it has very high speed. Fiber optic internet has very high speed, and that means it has low latency as well, right? It is highly resistant to any electromagnetic interference, right? And I forgot to mention that one of the limitations of cable internet is that the copper line that is used, or the copper wire that is used, that copper line is actually prone or susceptible to signal degradation, right? So you lose a stable connection because of let's say over long distances. Remember, fiber covers or is mapped around continents around the world. So fiber optic internet is a huge thing in the world, right? So it is resistant to those electromagnetic interference. That's fiber internet as well. And the long distance transmission is happens without any signal duplication or loss. You don't lose signal. Doesn't matter what the distance is of because it spans fiber spans like continents around the world. Right, but the problem with fiber internet is that it is quite expensive. It requires large